Thanks, Todd. The Lake Erie Whitefish report will be in the Coldwater Task Group report that Jim mentioned earlier on the GLFC website. There's two charges related to Lake Whitefish, a standard assessment charge, and then one that looks at knowledge gaps. And there's a Charge 8 report that's expected to be completed in 2018. Oops, wrong button. 8 agencies present on the Coldwater Task Group, lots of members that Jim made reference to. In addition, for the Whitefish summary reporting, I'd also like to thank contributors that provided either assistance with modeling, catch at age analysis, commercial data, other data sources, marine stewardship certification information, and analytical approaches with recruitment. This slide is essentially a summary slide for Lake Whitefish, the history of Lake Whitefish as described by harvest by jurisdiction from 1867. In the legend, the color codes represent the jurisdictions. In addition to whitefish harvest in thousands of pounds, there's also smelt harvest represented on the right axis for reference. The harvest of whitefish in the late 1800s was basically from seine nets, trap nets, pound nets, eventually shifting towards gill nets made of linen and cotton, eventually changing to multifilament nylon nets, and eventually monofilament nets in the recent era by the 70s. A lot of habitat destruction occurred in the Detroit River that has gained a lot of press in recent years in response to declining whitefish populations in the late 1800s, early 1900s. Hatcheries began stocking whitefish in Lake Erie and Detroit River with limited success. Despite that, several strong year classes emerged in the 20s, 30s, and 40s, and although Lake Erie is not considered one of the whitefish Great Lakes, there were periods in which whitefish harvest in Lake Erie was the highest in the Great Lakes. This era here, highest in the Great Lakes, and this era here during the 40s. Having said that, by the late 1950s, whitefish collapsed in Lake Erie, attributed to several causes, including overfishing, eutrophication resulting in habitat degradation in terms of quality and quantity, invasive species such as sea lampreys and rainbow smelt, which influenced mortality at different life stages. And you can see here the harvest of rainbow smelt taking off, achieving a maximum of around over 45 million pounds or so at one point, so which interestingly is comparable to the historic maximum harvest of Cisco. It was many years before there was a modest recovery of Lake Whitefish in the 80s that coincided with declining phosphorus loading, increase in walleye numbers following the walleye moratorium, and colonization by Dreissenid mussels. So at that point, smelt also were in a state of decline, and during this last 31-year period that we'll focus on for the rest of the talk, harvests have never achieved historic levels, albeit this period was referred to as an overfishing period, but the harvest was 5 times the maximum 1.3 million pounds achieved during the 90s. U.S. fisheries targeting fishing whitefish are primarily trap net fisheries. Ohio's fishery is the largest trap net fishery for whitefish in U.S. waters, averaging about 48,000 pounds over the past 31 years. In 2017, the harvest was 701 pounds. The maximum in the time series was 288,000 pounds. 18 boats in the fishery presently. They have electronic catch reporting and monitoring systems, and there are restricted areas where they can fish and can't fish. These areas are functionally lake whitefish sanctuaries, so they can't be fished during the spawning season and other times of the year. There's minimum length criteria of 17 inches, and in the other jurisdictions, Michigan also has a minimum length criteria of 17 inches, but the November harvest is prohibited, so often in recent years the catch is 0, and nominal harvest occurs in Pennsylvania and New York waters. There's only several licensed trap netters in both jurisdictions, and it wasn't until Pennsylvania ceased gill netting in 1996. Prior to that, the harvest achieved levels of 350,000 pounds, so there were definitely whitefish in Pennsylvania waters at the time, but the shift into gear regulations resulted in the highest harvest being around 4,000 pounds during the recent era. Ontario's whitefish fishery includes 58 gill net vessels. That's less than several over the past decades. There's been a decline due to industry consolidation. 188 licenses exist still in 2017, fished by fewer vessels. There's no formal whitefish harvest policy currently for Lake Whitefish. They've been managed indirectly really through walleye harvest policies, which share the same gear, large mesh gill net primarily. Quotas exist for Lake Whitefish. In 2017, the lowest quota over the 31-year time series, actually not 31, since 1984, ITQs were introduced. 60,000 pounds, the lowest in the time series. Fishers are required to fill out daily catch reports or DCRs. Weights are verified by port observers and weight observers. And in 2017 and since 2014, incidental catches occurred in gill nets targeting walleye, white bass, some caught in smelt trawls, and small mesh gill nets targeting yellow perch and white perch. Several trap net boats fish in Ontario waters, but due to their locations, they catch 0 whitefish. The harvest in 2017 represented only 51% of the 60,000 pound quota at 30,826 pounds. As a measure to reduce whitefish harvest, commercial harvest of whitefish in the West Basin could be transferred since 2016 into the Central Basin to alleviate the pressure on spawning whitefish or migrating whitefish. 6% of the harvest was transferred out in 2017. There is a Marine Stewardship Council certification in place for walleye, the large mesh gill net walleye fishery as of 2015, but there are conditions that relate to whitefish and white bass. The conditions related to whitefish specify that whitefish must remain within biological limits, and a partial management strategy is expected by 2019 such that the large mesh walleye fishery may not impede the recovery of lake whitefish or pose any serious harm. And there's evidence required of reduced harvest, protection of spawners, or that the whitefish are within biological limits and that the incidental catch is minimal. Progress to date has been the conservative quotas that eliminate the incentive to target lake whitefish, the walleye quota transfer from the West Basin to the Central Basin, reducing the whitefish harvest in the West Basin during spawning season and migration, and lake whitefish modeling by the Data Efficient Task Group and the Cold Water Task Group as well, along with looking at reference points that could be used for management applications. A quick summary of the last 31 years of harvest by jurisdiction. The blue series is Ontario's, representing the majority of the harvest over the years. Ontario's quota is depicted in a dotted line over this time frame. There was an 85% reduction in quota in 2013, and from that point on, we're just looking at incidental harvest. Spatial distribution of whitefish harvest in 2017, according to 5-minute grids on the North Shore and 10-minute grids on the South Shore. Any white areas on the map indicate no whitefish harvest occurred. The greatest harvest in 2017 occurred during the fall in the West Basin in Ontario waters west of Pelee Island. Some of the areas that typically exhibit significant whitefish harvest grids 801 and 804 and Ohio waters didn't experience any whitefish harvest this year in the trap net fishery. The color code here indicates the intensity of the color indicates the magnitude of the harvest, but the total harvest in 2017 was quite low, just over 31,000 pounds. If we look at catch rates in the large mesh gillnet fishery in Ontario, there are three forms of catch rates presented. Catch rates that target lake whitefish are represented by the black line, and that series goes up to 2013. The low quotas ended that series since incidental harvest was the only harvest occurring from 2014 on. The other two forms of catch rates described are catch rates associated with all large mesh gillnet and the red series catch rates with effort with whitefish in the catch. And although the heights on the graph differ somewhat, the trends are the same. 2016 and 2017 were the lowest in the time series and comparable during those 2 years. And just to illustrate the causes behind effort that is targeting whitefish, responsible for the whitefish harvest versus the incidental catch in walleye nets, we can see that over the time series here, the proportion of whitefish harvested by the targeted whitefish fishery peaked a couple times, and during those peaks, the coordinated perked management strategy had begun, and that was a period in which walleye quotas were lower. And then the next shift here to targeted whitefish effort was the recruitment of the 2003 year class, which is the strongest cohort in recent history, and targeted whitefish accounted for the majority of the harvest during that period. As whitefish recruitment declined in recent years, the proportion of the harvest in large mesh gillnets targeting walleye increased, and that time was coincident with the low quotas for whitefish as well. U.S. trap net catch rates in Ohio and Pennsylvania waters. There are values for 2017, but they're so low they're difficult to see. This time series includes some targeted effort seeking whitefish, but in 2017 it was all incidental harvest of whitefish, very low catch rates. The age composition of the fall West Basin fishery in Ontario. An interesting thing is the representation of younger fish in 2017. There was a trend of reflecting failed recruitment for a number of years, where only older fish in the age 7 and older group, which is represented as purple here. And then we see a sign of 2-year-olds in 2016, and then age 2 and 3 in 2017. And these two cohorts provide some cause for optimism following the major decline of whitefish in recent years. Interestingly, the 84 year class present here in 86 was the year class that contributed to the whitefish recovery, the startup in the 80s. So hopefully this does as well or better in the future for us. The age composition by target fishery in Ontario, just a quick comparison, that nets targeting walleye tended to catch younger whitefish ages 2 and 3, whereas the nets targeting white bass caught some of the older whitefish, and smelt trawls, small sample size but young of the year whitefish were present, which may be a good sign. Gillnet surveys that catch whitefish in Lake Erie include the Cold Water Assessment Survey, multi-agency survey conducted in the East Basin, in the hypolimnetic waters below the thermocline in the East Basin. Strictly a cold water species survey because of where the nets are fished. Partnership gillnet survey catch rates for the Central Basin, Pennsylvania Ridge area, and East Basin combined. For ages 0 to 2, so juvenile fish, and ages 3 and older are presented separately here. The cold water assessment trend is still low for 2017, the gray shaded area, slightly down from 2016. The partnership nets increased for both the age 0 to 2 age groups and the age 3 and older fish as well. Still relatively 3 and older still on the lower side for the time series, but the juvenile index is relatively high for the time series. And comparing the age composition from the two surveys, interestingly, the cold water assessment nets were composed mostly of older whitefish exclusively in the hypolimnion of the East Basin, whereas the partnership nets caught age 2 and 3 fish in a greater abundance throughout the East and Central Basin at a broader range of depths. Briefly discuss trawl indices that catch whitefish. They're generally considered as a general indicator of recruitment, but when considered in isolation. But if we combine all these indices, it has the potential to be very informative, potentially for management as well. In this case, Central Basin trawls in Ohio during June and October, Pennsylvania trawls and New York trawls represented here for age 0 whitefish. We can see the presence of the 2015 cohort, and even the 2017 is showing up there as well. Historically, there were some higher catches as you go back in time. I guess we'll see how these recruits turn out over the next few years, but it certainly suggests that conditions were more favorable for whitefish recruitment in past years. Similarly, if we look at the trawl indices for age 1 fish, we see the high catch rates in the late 80s, early 90s, lower catch rates in recent years, and also the drought period followed by recent recruitment indications, but still nothing compared to the earlier time frame based on the trawl indices. If we take the commercial catch at age information from Ontario's gillnet fishery and Ohio's trap net fishery, and in some cases when Ohio's trap net fishery is lacking age composition, we assume it's the same as the commercial gillnet fishery. And also we have the partnership index present in this model, catch at age model, that provides abundance estimates for ages 3 to 9 and older fish from 1994 to 2017. The age-specific abundances are color-coded so that you can see age 3 recruits are represented here. The biggest recruitment event, 2006, was the 2003 cohort. And the model, based on 1 year of information, is estimating a very substantial recruitment event with the 2014 cohort. The greatest uncertainty of all the years of information presented here lies with this black bar because the age group is represented once in the model. As years of data accumulate, and that cohort has represented more years, we'll have a better idea whether or not the optimism from this year remains. The same sort of information is presented here, just with total abundance of age 3 and older fish as a black line. But we've added recruitment projections and added them to age groups, assuming a survival rate from catch at age analysis in 2017, projecting the population forward to 2020. The reason there are two different trajectories here is because the 2014 cohort estimate here of 6.7 million fish was in quite a contrast with recruitment indices projected by principal components analysis and regression of 1.3 million fish. So we provided both projections just to sort of show the full, well, some degree of uncertainty and as we move forward with whitefish abundance in the future. The recruitment indices that were shown previously as young of the year yearlings and gillnet surveys at young of the year yearling in age 2 were combined in principal components analysis to yield first and second principal components to combine all these recruitment indices into fewer elements that could be used in regression with age 3 estimates in catch at age analysis to estimate recruitment moving forward. So the ability to forecast age 3 recruits into the future is very beneficial for management applications. Historically, throughout the Great Lakes, changes that have occurred in the food web have impacted whitefish, affecting their condition and growth and whatnot. That evidence has never really been observed for lake whitefish in Lake Erie, perhaps because Lake Erie is such a productive lake and that constraints in the population are occurring at earlier life stages. But some of the diet information that was collected in 2017 is presented here from Ohio DNR and also MNRF in Port Dover, collected a couple samples. Whitefish are eating amphipods, chironomids, cladocerans, bosmina, daphnia, and copepods. And a lot of this was June information. Chironomids very big in the diet of whitefish. Chironomids are very resistant to eutrophic conditions as well. But this bottom right-hand corner is just one whitefish that the stomach was just full of round gobies of various sizes, which was kind of interesting, but it wasn't part of any formal diet study. And that was March 2017 in the Central Basin. Just to highlight some important research being done by University of Toledo and USGS, Zach Amadon and Robin and Chris, Ed and Chris, are looking at the fate of lake whitefish eggs deposited in Lake Erie. And this is occurring in 2016 to 2018. They're using pumping eggs from a sled dragged over the reefs. And out of 31 locations that they looked at, they found whitefish eggs at 27 locations, which is very promising. So the locations where eggs were detected are presented in green here, and a few areas where they weren't detected with red squares. They're also doing a follow-up in the spring, looking at the densities and distribution of the eggs, and also the presence of larvae and the distribution of larvae in the spring as well. So really unique information for lake whitefish. Probably this type of information will add to the Goodyear Spawning Atlas section for lake whitefish, certainly. Stay tuned for Ed's talk this afternoon or later this morning on lake whitefish spawning in the St. Clair River and Detroit River and larval export from the Detroit River. A number of agencies are working on lake whitefish acoustic telemetry work in Lake Erie. Since 2015, whitefish have been tagged at the Maumee River mouth and also on Little Chick Island near Hen Island and Crib Reef, Ohio. So 152 fish have been tagged with internal transmitters and external fly tags with the idea of describing movements during and after spawning period, and also when these fish swim by GLaDOS system receivers throughout the Great Lakes, their habitat use, seasonal habitat use, will be described in great detail. Of the 152 whitefish tagged to date, 10 have been recovered by the commercial fishery. 9 of those were recovered in less than 2 weeks, and 1 was recovered 2 years after tagging. And this picture here just shows, this is Joe Battaglia measuring a whitefish after inserting a transmitter surgically and applying the fly tag. And after these fish are anesthetized with electrosedation and tagged, they're released immediately, and they all swim away within seconds of hitting the water. This is a tank where they're held just prior to the acoustic surgery. Here's a slide Chris Vandergood provided showing in 2017 from April to June where were whitefish that were tagged in 2015 and 2016, where were they found throughout the lake during this time frame. And the black dots indicate no detections by receivers, but the green dots, the size of them, indicate the number of whitefish, unique whitefish detected that were tagged. And it's an interesting result that during this time of year, so many whitefish were found in the Central Basin, and also puzzling about their lack of presence in the North Shore of the Central Basin. Some were detected in the West Basin during this time frame, but as we collect more information and download more data that's from the receivers that are still fishing or detecting over the winter, we'll have a much more clear picture of whitefish movements on a seasonal basis in response to climatic conditions and based on spawning behavior and that sort of thing. So, in general summary, the fisheries were non-target fisheries in 2017. Lowest harvest in 31 years, 31,500 pounds. Population status was poor. It hit rock bottom in 2016 due to poor recruitment events. Whitefish population is showing some signs of improvement in 2017, and we're expecting to see more improvement in 2018 as the 2015 cohort contributes to fisheries and surveys. Efforts to support management have focused on population modeling and recruitment forecasting. Those are great tools to use with which to support quota management and other regulations. The Data to Fishing Group and the Coldwater Task Group have been looking at a variety of biological reference points as the basis for measuring the status of lake whitefish. The Marine Stewardship Certification process for the large mesh walleye gillnet fishery is fostering stewardship for whitefish and moving the bar for whitefish management. Research addressing knowledge gaps, the telemetry work being done, and efforts focusing on early life stages of whitefish, egg deposition, early life stage survival. All this is information that is very novel and should be useful in the coming years for managing whitefish. Thank you.